Congratulations on finishing section 1 of the Python security module. We're now launching into the section 2, which is more secure, and we're sanctifying by using a cheeseburger. So the basic security was the hamburger. Now we're getting more fancy and adding cheese onto it. In order to do this, we're going to create a separate API server. And instead of storing the password in the environmental variable as clear text, meaning that someone gets it, they can see it, we're going to use something called a hash. And so the first lesson today is about hashing. We have our cook, Alice, here, and she's making corned beef hash. So a hash is when you chop up all the food and you stir fry it. In technology, when you say the password is hashed, or you turn the password into a hash, so the password might be clear text, or Sunset Diner 2026 is the password. Username for the cook is Alice, but the hash is going to be a scrambled set of characters. You can't turn this hash back into the original password. I guess it's similar to cooking a hashed dish where you can't turn the corned beef back into a solid piece of meat. And you can't do that for the potatoes either. So once it's scrambled together, you can't recombine it. So for password hashing, the developers and the database administrators cannot see the original user passwords once they're hashed. And so this is a good way to store it. So this center one password is never stored. The starting point of this tutorial is lesson 4 of our course. We could open it up here. I'm going to reorganize the code a bit. So I'm going to create a new folder, and I'll call it API server. And I'll create another folder, and I'll call it Frontend. The current app.py, I'm going to move into Frontend. And the static folder, which just has this image, I'll also move into Frontend. Within the API server, I'm going to create another folder called admin. This is admin tools for the API server, and the API server will also handle our authentication. In our architecture, even if the person hacks into the front end server here, they still won't have access to the hashed passwords. They'll have to figure out where the API server is, somehow hack into it, and then grab the hashed passwords. But even with that, it's unlikely they'll be able to unscramble it. The separation of the front end and the back end does offer an additional layer of security just by separation. I'm going to use UV to add the package that we'll need for hashing, which is called Passlib, and it's called crypt. I'm going to put this in quotes. And I'm also going to add a package called bcrypt, which I will add directly to my pyproject.toml. So bcrypt. And I want it to be less than 4.1. Then I will use UV sync. Okay, within the API server, the admin, I'll create a new file, create hash.py. I'm going to, from passlib context, I'm going to import the crypt context. Now I need to set up the password context with the crypt context. So password context equals crypt context. And schemes, we're going to use the bcrypt, which we just added. Bcrypt, and the deprecated will be auto. So I'll have for a test. Password context. So let's see whether it works. Python, then API server, admin, and it's the create hash. So it's creating the hash right there, which is quite long and quite nice. Okay, so for the purpose of this demo, normally you're not going to write it down here. You'd have it run in from the command line, but let's see, for the purpose of this demo, let's just copy it in. Let's see. Create a folder called secrets. In here, we'll create a file called shadow or shadow passwords. We'll have Alice, and then she will have her hashed password here. And actually, I think I will change this so that you don't have to hard code the password in. We use something called argparse. And then we'll do def create password, which will receive the password from the command line as a string. So it might be in the command history, but at least it's better than having it be in here. And we'll return the okay, so in our main, we'll have a parser to catch the command line arguments. Argparse, argument parser. String. So with the parser, we can grab the arguments, parse args. Then we can print it out. And then we'll run the main program. Okay, so let's try it out. This is the password, and this is the hash. This tutorial uses the hashing algorithm bcrypt. And when you're designing your security system, you should stand on the shoulder of giants. You don't want to design your own security. You want to use a very proven, very tested method. Bcrypt is still the most widely used password hashing system in the world. It's used in Django, Flask, Ruby on Rails, Laravel. It's created in 1999, so it's a bit old. It's designed to be slow, and this is to limit the cracking attempts, right? So when you create the hash, it's intentionally slow. It replaced the fast hashing algorithms MD5 and SHA1, which were historically very popular. In our program, we're using a Python module called Passlib, and Passlib automatically generates a salt, which is a random string that is applied to each password. So every time you have a password that's sent to the system, a new random salt is generated. And that random salt is actually part of the string of seemingly random characters that is returned when you hash the password. So even if you have two people with the same password, let's say their password was password, if you hash it, they're not going to look the same. That would be a horrible password to use, by the way. It's important to note that the industry is moving towards something called Argon2. You can easily use this hashing system with Passlib by switching bcrypt to Argon2. Another very popular one is scrypt, which is actually older than Argon2. So because of the processors are getting faster, people are using GPUs, people are using big systems to try to crack the hash tables, the hashed passwords. People are moving to Argon2, but the world is still on bcrypt. And the concept is very similar. So because we're using Passlib, you can simply change bcrypt to Argon2 or scrypt. Right here, our scheme is bcrypt, but we could theoretically add Argon2 or scrypt to it. And in our dependencies, I have specified bcrypt and a slightly older version because the current Passlib 1.7.4, it was actually looking for an slightly older version of bcrypt. It's still secure. In our next lesson, we're going to create an API server using the Python project Fast API, which will verify the hash and communicate with the front-end Shiny server. I'm organizing the code, the slides, and other things into this free course. It's in Chapter 14, Security, and I'm going to put this video that you're watching as Lesson 5. And then at the bottom of the video, I just realized I can add the the download for the code here as well too. Currently, I have it as a separate download. We can get the zipped file for the code for the previous lesson, but I'm going to reorganize it so that they're all together. If you have a moment, join the free course, industry-python.thinkific.com. 100% free. There's no credit card. We're just trying to see if there's interest from the community in this type of information.